I'm Lisa, and this is Jenny.
Hi.
And we are two of the scientists on the Icy Worlds Kickstarter. And we're going to tell you a little bit about what we do in our lab and what we're hoping to do with this project.
So we work in the high pressure experimental metrology lab, where our tagline is "We build planets." What we mean by that is that we investigate the interior of planets, how they form and how they evolve. So we're standing here in front of the multi-angle press, which is the instrument in our Kickstarter. And we use this to do very high temperature and high pressure experiments to study the inside of planets, how the core of a planet forms, how the mantle forms, and how planets go from formation to how they currently are. Mostly what we study is the interaction between liquid metal, which is the core, and the silicate rocky portion of the planet, which is the mantle, and how the metal and the rock interact. But this is mostly based on the Earth, which is represented in this rock, which is a rock from the Earth's mantle. Because we know something about the Earth's mantle, we can apply that to other rocky planets in the solar system. But we don't only have rocky planets in the solar system, they only exist inside the asteroid belt. Lisa's going to tell us about outside the asteroid belt.
That's right, because there's a whole different part of the solar system that has abundant ices. And we've seen from recent missions like Dawn and New Horizons that this outer solar system environment of planets is really dynamic and very active. There are volcanoes, there's mountain building, there are faults. So one thing we don't really know that much about is how that ice and rock interact in an interior setting in these planets. So what we want to do is take our instrument that we're normally working at very high temperatures, again, this is 2300 degrees C sometimes, and we want to outfit it with a liquid nitrogen cryo system so that we can study the interior of these outer planets. And it's a big giant press, but that system will be looking at these tiny, tiny experiments. That's how we get into planetary interiors. So some of the exciting things about this is that these ices might transform into a liquid. So there might be liquid water, for example, in the interior of an outer planet. And then that means that there's the potential for life in the outer planets. So the next step will be to do some experiments that have ice and rock. We're going to study that interaction, but then also add organic compounds into that mixture at pressure that hopefully will help us answer some questions about whether or not there is the potential for life deep inside these outer planets.
So Terry the T-Rex asked you to please vote for our Kickstarter. Vote for us.